So in this video, we're going to be going over using intercepts of linear equations, okay? So usually we're going to use intercepts when we're in a standard form, okay? And in a later video, I'm going to show you how to convert an equation into standard form, okay? But for now, we're going to define what standard form of a linear equation is and then how we use it to find the intercepts, okay? We're also going to calculate the x and y intercepts from a linear equation that's in standard form, and we're going to use those intercepts to help us graph the linear equation or function. All right, so first let's define these three things we're going to be working with in this section, okay? The x-intercept is the x-coordinate of the point where the graph crosses, okay, intersects the x-axis. That point is always going to have a y-coordinate that is 0, okay? So the x-intercept is always going to have a y-coordinate of 0, and it's going to be where the graph crosses the x-axis, okay? The y-intercept is going to be the y-coordinate of the point where the graph intersects the y-axis. Okay, so where the graph crosses the y-axis, that is going to be called the y-intercept. At that point, the x-coordinate always is 0. Okay? Standard form. So standard form of the equation is going to be this. It's ax plus by equals c. Okay, now there's some limitations for a and b here and c. They all have to be real numbers, and they all have to be integers. Okay, you're not going to have fractions for a, b, or c. You're not going to have decimals for a, b, and c. They can be positive, they can be negative, okay, but they're going to be integers. Okay. One other thing here, okay, a and b cannot both be equal to 0. If they're both equal to 0, then you don't have a linear equation anymore. You have to have an x or a y to have a linear equation, okay? All right, now one other thing, or a couple other things we got to go over, okay? First, x and y both have exponents of 1. So if you'll notice this x, there's an understood exponent of 1. For the y, there's an understood exponent of 1. If you have an exponent other than 1, okay, then you don't have a linear equation anymore. Okay? You might have another function that we might be dealing with, but it won't be linear. Okay? Next thing, x and y are not multiplied by each other. Okay, notice we've got an expression here that has x in it. We've got another term here that has y in it. Okay, they're not multiplied together. It's going to be a sum or a difference there. Okay? And finally, x and y do not appear in the denominators, in the exponents, or underneath radical signs or square root, cube root signs of the like, okay? So x and y are always going to be in the numerator. They're always going to have an exponent of 1. You won't see any exponents other than the 1 in order for this to be a linear equation, okay? All right, so first thing we want to do here, use the graphs to find the x and y intercepts. So let's look at this graph first, okay? You can see it's a linear equation because the graph is a line, okay? First thing we want to do is find out what is the x-intercept. So where does this graph cross the x-axis? And it looks like it's right here, okay? And that value is -4, okay? We're 4 units, 1, 2, 3, 4 units to the left of the origin. So my x-intercept is going to be -4, okay? We want to be able to understand the x-intercept's -4, but we also want to be able to write that as an ordered pair, okay? Remember, we said the x-intercept always has a y-coordinate of 0, so the x-intercept of -4 corresponds with the point -4, 0, okay? Look at the graph now and see where does it cross the y-axis, okay? So the origin's here at 0, 0. We're going down, so y is going to be negative, so -1, -2, and -3. Okay, so that's where the graph crosses the y-axis. So y-intercept is -3, which corresponds with a point of 0, -3. Remember, the y-intercept always has an x-coordinate of 0, okay? Pause the video here and try this second graph, okay? Try to determine the x-intercept and the y-intercept, and then come back and check your work. Okay, so the x-axis is here. The line, again, it's a linear function because we have a graph of a line, crosses the x-axis at this point. So we're left of the origin, so we're left 1 unit, 2 units, so the x-intercept is going to be -2, okay, which corresponds to an ordered pair of -2, 0. All right. The y-intercept is above the x-axis this time. It's above the origin, so we're going up, +1, +2, +3. So the y-intercept is 3, which corresponds with a point of 0, 3. Okay? So that's how you can look at a graph of a linear function or a linear equation and determine what the x-intercepts are.